Okay, so let's get into our next video on airspace classification and operating requirements, and also kind of going into flight risk restrictions within the national airspace system. And really what we're going to kind of get into is kind of focusing on the different airspace classes and kind of understanding a little bit about reading aeronautical sectional charts and kind of what the FAA wants us to know. Specifically wants remote pilots to understand about the various airspace classes within the national airspace system. So when we're getting into it, airspace is basically divided into two categories, which are regulatory and non-regulatory airspace. Now, within these two categories, there are four types of airspaces that we typically have to work with. These are controlled airspace, uncontrolled airspace, special use airspace, and what the FAA is going to classify as other airspace. Now, the National Airspace System, as you can see in our graph, is comprised of Class A, Class B, Class C, D, E, and Class G airspace. The Part 107, however, is only going to require knowledge of Classes B through G airspace, and incidentally, there actually is no Class F airspace within the United States, in case you were wondering. But Class B through G airspace is going to fall underneath that regulatory airspace that I just mentioned a minute ago. So all of that is kind of our primary area that we have to focus on. Now, we do also need to know about the non-regulatory airspace as well. And what the FAA considers as non-regulatory airspace includes the following. It's prohibited, restricted, warning, military operation alert areas, and controlled firing areas, where all of those areas the FAA is not going to enforce those controlled airspace. It's basically a generic term that's going to cover the different classifications of airspace. So the defined dimensions within which air traffic control, the ATC service, is provided in accordance with that particular airspace classification. Now, controlled airspace, that is kind of our primary concern for remote pilots. Those areas are Class B, Class C, Class D, and Class E airspace. Whenever a remote pilot is going to be planning to actually fly any operation within controlled airspace, they have to receive FAA authorization before operating any device within that airspace. So typically what you might see, especially in say like Bellingham area, we're operating in say you might look at say like Class B airspace or Class D, depending on where you're at. So Class B airspace is generally airspace that's going to run from the surface of the airport up to 10,000 feet mean sea level, or MSL, and surrounds some of the busiest airports that we typically deal with. So this is going to be really more if we look at say like SeaTac or Los Angeles or say like Chicago. Those are kind of the more where you're going to see pretty common Class B. So Class B airspace is controlled airspace, and it's individually configured based on an area's natural terrain and different man-made objects, and consists of a surface area with two or more layers that you'll typically see. Generally are going to look like kind of like an upside down cake, specifically like a three-tiered cake. So if you want to think of it as anything, maybe a wedding cake. If you had a three-tiered wedding cake, I just had a one-tier. When my wife and I got married, we weren't that fancy. Now, as you can see, kind of on that center of that Class B airspace, it extends from the surface and extends outward about 5 nautical miles, and then extends upward to approximately 10,000 feet MSL, or mean sea level. And that's on average, give or take. Some classes of controlled airspace could extend up to, say, 11,000. It could only extend up to 10,000, and that kind of goes the same with Class D airspace. It really just depends on kind of the natural terrain, but the center of this Class B airspace typically will extend outward from the center of the airport out about 5 nautical miles, and again that altitude can vary on that first larger shelf that we see. So it can begin at roughly 1,000 to 2,000 feet MSL, and then it can extend outward about 10 miles from the center of the airport, and then the second shelf of the airspace can begin anywhere between 3,500 and 5,000 feet MSL, and again will extend up to the top ceiling of approximately 10,000 feet MSL, and outward about 15 miles from the center of the airport. Now, in Class C airspace, which is denoted in the magenta, it will extend out about 5 miles from the center of the airport, and then the second shelf will begin at roughly about 1,200 feet MSL, and it will extend up to roughly about 4,000 feet MSL. And the center of the Class C controlled airspace will extend out typically about 10 miles from the center of the airport. Class D is going to be denoted in an aeronautical sectional chart as a dashed or dotted blue line, and that will begin at the surface and it will extend out up to about 2,500 feet MSL. Now the dotted magenta is a Class E airspace, and Class E airspace can kind of be one of the more confusing types. We're going to go into it a little bit more in detail here in a little bit, but for now I kind of wanted to point it out. That can be denoted as either kind of a dashed or a dotted magenta circle on aeronautical sectional charts, and it will extend upward until it runs into a shelf of an overlying other class. So airspace control class like Class C, this could be Class E airspace, and it can hit the bottom of this Class C shelf. So it can end at 700 feet AGL above ground level, when it may run into a different type of Class E airspace, which is the shaded blue. It is also a Class E airspace. And this 500 feet MSL Class E airspace typically is found in the western part of the U.S. where we're seeing kind of where we're at, and generally at kind of higher elevations. Now, here we're kind of looking at a two-dimensional downward look, and this is what you'll kind of see with most aeronautical sectional charts. And now this is a Class B airspace, and again it's denoted on a sectional aeronautical chart with solid blue lines or symmetrical circles. Now, it's not always totally symmetrical, but again the inside of the airport, which is that very center dot, which I can kind of show you right there, that's our primary area. Now you can tell that is the airport area because it's denoted by the blue runway icon strips when we actually look at an airport, and they'll be shown in these kind of runway patterns and denote the direction of the landing strip itself. So the runway that we're kind of looking at is we have a couple different options. So we can see that with that icon there is a northeast and then also southeast different icons, and also north-south kind of runway from what we're looking at, and those are kind of different runway patterns. So a couple things to kind of look at when we're looking at this is the numbers, that how we're kind of seeing things. So the FAA removes 2 zeros typically from the numbers to kind of simplify the airspace and kind of limit how much is on the map, because there's already quite a bit on the map as a whole. So you can see what I've kind of circled in red there. We have a 100 feet SFC. So what this means is that 100 really means 10,000. So on any of these aeronautical sectional charts, the FAA removes the last two digits to simplify how, or two of the zeros to kind of simplify the airspace. So that denotes 10,000 feet MSL, mean sea level, where SFC is surface up to 10,000 feet MSL, is what we're saying there. So the center within 5-mile radius of that airport runs from the surface up to 10,000 feet of the first shelf of the airspace. And you can see kind of that first shelf or that first circle as well, in that kind of immediate area, kind of right where I circled those 100 SFCs. You can kind of see the additional section here. Might be a little hard to see my mouse, but you can kind of see the initial ring that we have up to that shelf. So typically it'll extend out about 10 miles, but as I'll point out here on the bottom part, 10 miles, but then if you can see, it cuts out to the top and extends outward a little bit. So you can see it cuts out right there and extends outward. It comes around kind of over on that west side of the airport and bends around that little area. So this airspace, that first shelf of that airspace, runs from 1,800 feet MSL up to 10,000 feet MSL. And then the second shelf of airspace, so that's our first shelf that we see. Sorry, I should have kind of gone to that. So that's our first shelf. So our second shelf that we see, as denoted there, has a lot of kind of cutouts through it. And there's quite a few different shelves of the airspace in this one. So we can see, I want to kind of point out that that airspace, that shelf of airspace, cuts around the airport, but you can also kind of see another airport in magenta there. And that denotes that it's an airport that does not have an operating control tower. It only works off of radio frequencies, which we'll kind of get into a little bit later down the line. Now, the star above each of those airports, if you can kind of see that, is a regional, or a star, that indicates there's a lighted beacon. You may or may not be able, or that there's just a lighted beacon. So when we're looking again more at these sectional lines, if you're, say, hired to operate a small unmanned aircraft near these airports, you need to be aware of the size of the airport and the traffic, the corresponding traffic around that second shelf of airspace in some sections. So typically that second shelf begins at 5,000 feet MSL. And again, it's kind of denoted in these fractional numbers that you see. So that 100 divided by 18 there. So again, those 2 zeros are missing, and it extends upwards to a ceiling of 10,000 feet MSL. However, there are a few areas where the lower shelf of the airspace is going to begin at 600 feet MSL, and then another area by that little cutout there that airport is over on, it might begin at, say, like 4,000 feet MSL. And again, it begins at various altitudes based on the terrain and other man-made air objects in that area, and traffic and departure approach patterns as well. So there's kind of a lot to kind of think about, and especially this is something that we have to think about too if we're going to be flying in, say, the Bellingham area. So anything within that first kind of 5-mile radius of, say, Bellingham International Airport, we typically are going to have to get FAA approval to fly at any point in time. So we can kind of see again, this is kind of our upper layer that we'll see of that Class B airspace. Again, you can see that extra kind of airport that I've kind of pointed out there again. We'll kind of move on just a little bit. Now that one additional area that we have there as well, we'll talk about a little bit later, but we'll kind of move on into kind of our next area, which is our Class C airspace. So this is our Class C airspace, which is shown in our solid magenta line circle, and it's generally, again, airspace that's going to run from the center of the airport outward about 5 miles, and it surrounds airports that have an operational control tower, and it's also typically serviced by a radar approach control. They can also have a certain number of instrument flight rules, or IFR operations, that again services somewhat busy airports and passenger aircraft. Like all controlled airspace, Class C is individually tailored, and it usually consists of surface area, again, within a 5 nautical mile radius from the center of the airport, and again is going to extend upward approximately about 4,000 feet, but like this airport that we're seeing here, it really depends on where we're at. So it runs from the surface, but is going to extend upwards. So you can see that first one, and that's our second area, but it will extend upwards up to 4,100 feet MSL. So it extends 100 feet higher, likely due to typically, say, like natural terrain. Now, a couple things to kind of note is what that airport icon kind of looks like as well. So that blue striped icon for the airport runway is going to indicate to us that the shortest runway there is greater than 8,069 feet in length. So the first shelf of airspace is 10 miles outward from the center of the airport. And it's going to start at the lower shelf, which starts at 300 feet MSL, and is going to extend upward up to 4,100 feet MSL. Now, we also want to kind of point out, if we kind of look at it, that Class C airspace is going to be sitting on top of a shaded magenta circle that I've kind of pointed out there. Now, that is Class E airspace. And again, like I said, we'll talk a little bit more about Class E airspace, but I wanted to point out that what that shaded magenta means is that shaded magenta means that directly underneath that area is Class E airspace. So the solid magenta circle that we're looking at outside of there, sorry, I jumped around a little bit, that's also, want to point out, that's another Class D dashed line delta airspace to kind of the southeast that we're looking at. So that's where we're seeing that dashed line can kind of be some Class D airspace. So what you will see inside of that inside of that Class D airspace is a blue bracket, and inside of that it's going to say a 25, and again it's missing 2 zeros at the tail end of it, so that's Class D airspace, which runs up to 2,500 feet, so it runs from the surface up to 2,500. Now above 2,500 feet, because this is part of Class D airspace, is now sitting within the Class C airspace. And Class C airspace is going to take over from the top of the Class D airspace and continue up to 4,100 feet MSL. So we have here is a group of what is called obstacles in kind of our next section here. Now, these obstacles are, that icon denotes that it can be potentially man-made obstacles typically. So we're looking at what's likely going to be, say, like cell towers or broadcasting towers. Now, it's very important for us, from a remote pilot perspective, to note of these items and how they relate to controlled airspace. So if hypothetically we were going to be hired to inspect some of these cell towers, we would need to know how tall they actually are and whether they're protruding into any controlled airspace. So in that bottom right hand corner, you'll see a number, and a number in parentheses. You'll see a 1,545 feet, which indicates the height of the tallest obstacle or tower there, which is MSL. And the number on the bottom is AGL, so above ground level. So we can see that we're not very high above sea level there. So if you were hired to inspect the top of this tower, you're allowed to fly your small unmanned aircraft within a 400-foot radius of that tower to the top of it. And you would legally be allowed to fly up to 1,532 feet, actually go up another 400 feet if you needed to, provided it doesn't go into any controlled airspace, since we know that shelf of airspace, Class E, begins at 700 feet AGL, and that Class C airspace, MSL, is 300 feet from the shelf. So overall, we're okay in that kind of area. So here we're looking at Class D Delta airspace, and we've kind of talked a couple times. I've mentioned, at least I hope, that Delta airspace is, or Class D airspace, is represented by a dashed blue or dotted line, and it's generally the airspace that runs from the surface at the airport up to 2,500 feet MSL, and it surrounds many airports that have an operational control tower. And it again typically extends outward about 5 nautical miles from the center of the airport. Now, in this particular group of airports, which is what I'm kind of showing you here, if we were actually flying in this area, we could actually step outside this area and fly a drone commercially without having to get an FAA approval for some areas, but not in this area. In this area, if we tried to walk outside, no matter what, we'd have to get FAA approval. And that's kind of what you have to do too if you live in Bellingham right now, depending on where you live, because we're within a 5-mile radius of the Bellingham airport. So again, we have 3 airports here, and actually each airport, if we look at, there's a primary airport right in the center here, and then we have 2 military airports within that area as well. So we actually have the Langley Air Force Base and also the Fort Eustis, and the one in the center is a commercial airport, the Newport New Williamsburg International. But in this Class D airspace, one has to obtain FAA approval, and the ceiling for this, as we can see with that in that bracket line of 25, again that means that it is a ceiling of 2,500 feet MSL. So in this airspace, which is again controlled, it runs from the surface up to 2,500 feet. Now, another thing to kind of note, so again, these are two additional airspaces there. Down here at the bottom here, there's actually another commercial airport as well as another military base, which is a Class D airspace that also has a ceiling of up to 2,000 feet. So that particular airspace runs from the service up to 1,999 feet MSL. And I'll kind of go into a little bit further here, and we'll kind of review it in greater detail about how Class D works in conjunction with Class C airspace. But it's sitting within that, and because of that, I kind of wanted to point it out. Now, there's also some Class E airspace, which is attached off of that Class D airspace, which allows for a little bit more clearance for approach and takeoff. And you can see this runway on Fort Eustis there, how it runs diagonally, so just to provide a little bit more approach and landing. So the next thing that we're going to kind of get into is Class E airspace, which is pretty predominant throughout the U.S. And what I'm showing right here in this section, which is, I know, really hard to see, but just trust me that this is kind of just a small section. It's taken from kind of the East Coast or eastern side of the United States. And so this is kind of what we're going to be looking at with this area. Now, Class E airspace is going to be denoted with that shaded blue, and you'll see that primarily out in our neck of the woods, which is the western United States and at higher elevations. But it makes up a lot of our airports. And now, a couple things to kind of note too that I want to point out is you'll see a lot of these little blue or green or red dots located on this map. And now what we're seeing here and how I actually got this map is through a website that we're going to be using for a lab a little bit later called skyvector.com, which is a really, really great resource that we can utilize. It'll show a lot of information, such as the dots will actually provide helpful information, so you can actually click on them or hover over to learn about airport data information, important information such as temporary flight restrictions or noticed airmen, and what temporary flight restrictions might actually be in place at that time. So very good information. We'll be looking a little bit more in depth into and practicing how to actually read some of these aeronautical charts. So we're going to kind of move in just a little bit and kind of move forward. And so in our Class E airspace, the dotted and dashed circled magenta is Class E controlled airspace that runs from the surface up to the next overlying airspace. Now in this case there is no overlying airspace, so it does not extend, so it does, sorry I said does not, it does extend up to 17,999 feet. So again, sorry, so 17,999 feet, which is basically up to the bottom of Class A airspace, and that is all controlled airspace. So that's kind of an important thing to note, is that our Class E runs all the way up to the tippy top, up to Class A. So, however, also what we see here is Class E airspace, again showed in our kind of shaded magenta circle, and inside that airspace begins at 700 feet, and so inside there it'll run all the way up from the airspace up to the from the surface up to 699 feet AGL. And in that area, that's what we see as Class G, or uncontrolled airspace. So hopefully that kind of gives you a little bit of a better idea of the different kind of airspaces that we have to kind of work with and deal with. So again, uncontrolled airspace, or Class G airspace, is the portion of airspace that has not been designated and extends from the surface to the base of an overlying Class E airspace. A remote pilot is not going to need authorization to operate in Class G airspace. However, if that Class G falls within controlled airspace, then, however, FAA authorization is actually required. So next thing that we kind of look into is what's known as special use airspace, or special area of operation, also known as SAO. This is the designation for airspace in which certain activities must be confined, or where limitations may be imposed on aircraft operations that are not part of those activities. Now, this includes prohibited areas, restricted areas, warning areas, military operation areas, also known as MOAs, alert areas, and controlled firing areas, also known as CFAs, is how they're going to be denoted. So prohibited areas contain airspace of defined dimensions where the flight of an aircraft is prohibited for security or other reasons associated within the national welfare. The areas is going to be charted as a P, so you can see that in the icons there. You can see the section that calls prohibited in the bottom left hand corner with a P49, or if you look over in the bottom right hand corner, you can see a prohibited mark with a P67 mark. So some of those national areas that we look at are going to be, say, like Camp David or Washington, D.C., basically all of Washington, D.C. So then we have restricted areas. These are areas where operations are hazardous to non-participating aircrafts. They're going to be marked with the wired lines in an image listed below, and they'll be denoted by the existence of unusual and often invisible hazards to aircraft, such as artillery firing, aerial gunnery, or guided missiles. So entry of these restricted areas without authorization from the using or controlling agency may be extremely hazardous to the aircraft, and restricted areas are typically going to be charted with an R followed by a number such as R5306, which you can see in the bottom left hand corner there. If you look over in the bottom right hand corner image, we can see an R5313A, or R5313B, or C, or D, which give you an idea of kind of what those restricted areas actually are. So while it is permissible for a remote pilot to fly within a restricted area, it is highly recommended that you do not. Warning areas. These are areas similar in nature to restricted areas. However, the U.S. government does not have sole jurisdiction over this airspace. So a warning area is going to be an airspace or defined dimensions extending from 3 nautical miles outward from the coast of the U.S., and it's going to contain activity that may be hazardous to non-participating aircrafts. The purpose of such areas is to warn non-participating pilots of the potential danger, and a warning area may be located over domestic or international waters, or both, and it's going to be designated with a W marker, followed by something such as, say, in the bottom left-hand corner, you can see warning W50B, or if you look over in the right-hand image, you can see W137 or 138. Military operation areas are areas that consist of airspace with defined vertical and lateral limits that are going to be established for the purpose of separating certain military training activities from instrumental flight rule traffic, IFR. Whenever a MOA is being used, non-participating IFR traffic may be cleared through the MOA if IFR separation can be provided by the ATC. Otherwise, ATC is going to reroute or restrict non-participating IFR traffic. Although ATC manages the NAS, each pilot is responsible for collision avoidance in a MOA. Defined on the back of the sectional charts with times in operation, altitudes affected, and controlling agency phone numbers, as well as via radio frequency for access and communication. MOAs are named, not numbered, such as the Phelps A MOA. And you'll also note the red rectangle, which will see a request status box, which is going to have a frequency of 119.75, which is the radio frequency that you can utilize to gather additional information. We have alert areas. These are areas that are depicted on aeronautical charts to inform non-participating pilots of areas that may contain a high volume of pilot training or an unusual type of aerial activity. Pilots should exercise extreme caution in these alert areas, and all activity within an alert area should be conducted in accordance with regulations without waiver. So pilots of participating aircraft or pilots transiting the area, as well as SUASs, shall be equally responsible for collision avoidance. Alert areas are going to be depicted with an A followed by a number, such as if you see in the bottom left-hand corner, an A531, or if you look over in the right-hand image, you can see an A292. Controlled firing area, CFA. CFAs contain activities that could be hazardous to non-participating aircrafts, if not conducted in a controlled environment. The difference between CFAs and other special use airspace is that activities must be suspended when a spotter aircraft, radar, or ground lookout position indicates an aircraft might be approaching the area. There is no need to chart CFAs, since they do not cause a non-participating aircraft to change its flight path, and they will not appear in NOTAMs either. Local airport advisories, also known as LAA. This is an advisory service provided by flight service facilities, which are located on landing airport using a discrete ground air frequency or tower frequency when the tower is closed. LAA services include local airport advisories, automated weather reporting with voice broadcasting, and a continuous automated service observing system, ASOS, or automated weather observing station, AWOS, data display. Other continuous direct reading instruments or manual observations available to the specialists. So what you'll see below shows an ASOS and an AWOS airport frequency. So you'll see ASOS 128.325 and AWOS 124.675, each in the left-hand and right-hand corners there. We also have our military training routes, MTRs. These are used by military for conducting low-altitude or high-speed flight training. Typically the routes above 1,500 feet AGL are flown under Instrumental Flight Rules, IFR, and the routes flown under 1,500 feet AGL are flown under Visual Flight Rules, VFR. On a sectional chart, MTRs are identified as IFR, IR, and VFR, VR, followed by a number, and this information is displayed in a straight line with an arrow. MTRs with 4 numbers denote routes flown at 1,500 feet above ground level and below. At such low altitude, this can present challenges to an SUAS, and so MTRs with 3 numbers or less are going to denote routes flown above 1,500 feet above ground level. The numbers following IR and VR don't depict altitude They're just there for their own specific reasons. So if you've ever been down to, say, like Arizona, specifically the Goodyear side of things, which is just a little, if I remember right, it's west of Phoenix. I could be remembering that incorrectly, but there's a military base out there where they fly F-35s and F-16s for military training. So you'll see military training routes there. You can also use that site that I mentioned not too long ago, SkyVector, to kind of take a closer look as well, which is pretty cool. So, NOTAMs. These are what we call notices to airmen. This is a notice containing information concerning the establishment, condition, or change in any component, facility, service, procedure, or hazard in the national airspace system. The timely knowledge of such information is essential to personnel concerned with flight operations, and since this information cannot be known sufficiently in advance to actually publicize by other means, it's imperative for remote pilots in command to check NOTAMs before each flight to determine if there's any applicable TFRs, temporary flight restrictions, that might affect flight operation. So final slide here, we have temporary flight restrictions as well. So these are issued using NOTAMs and are clearly labeled in bold red letters and are outlined on a sectional chart. The TFR will state the nature of the restriction, such as aerial demonstration or visit by a very important person, followed then by the effective days and times of the airspace affected. The FAA may approve SUAS operation in a TFR with prior authorization and approval, and some TFRs, like say around Disneyland, are not temporary, as say those shows are going to be 24/7, where they always have the nightly fireworks shows out there. And some of the purposes are for some purposes of establishing a TFR are to protect persons and property in the air or on the surface from an existing or imminent event, provide a safe environment for the operation of disaster relief aircraft, and prevent an unsafe congestion of sightseeing aircraft above an incident or event. So hopefully that kind of helps. If you have questions on any of this, again, feel free to reach out. I know that was kind of a lot of information, but happy to go over it further one-on-one if you have any questions. So, see ya.